Hello students, my name is Alpa Rupala, Assistant Professor from LG Institute of Engineering and Technology, Computer Department. Welcome to the lecture series of Mobile Computing and Wireless Communication. Continuing with our unit number 2, subtopic Coding and Error Control. Topics to be covered in this lecture. First of all, we will learn about the error correction technique, that is convolution code. Then after, we will look for the sliding window protocol and then ARQ. First of all, the error correction technique. The error correction technique is basically divided into two parts. First of all, we need to detect the error, and then after, we are correcting that error at the receiver side. Now you already know that we have learned in a previous lecture one of the error correction technique, that is Hamming code. Now in this lecture we will continue with this topic with the convolution code. Now first of all, what is the requirement of convolution code? Because there is the disadvantage in Hamming code that first of all, this technique is according to the single bit correction. We can only correct the single bit error. Second one, we require large bandwidth because the data code or code sequence is in very large amount of. And secondly, we are adding the extra bits, the redundant bits for error control mechanism, and which also increases the size of your data. Third, the extra parity bits which are added is reducing the bit rate of your transmission. And due to the large length of your block code, overhead is being reduced of calculation of your error control. But due to this large block, at the receiver side, receiver has to wait until all or whole the data packet is not being received. So due to this all the disadvantages, we are moving forward for the next technique, that is convolution code. The convolution code is basically overcoming the disadvantage of Hamming code. Convolution code is also known as the tree code. How it is overcoming? So first of all, we are dividing our data into small message parts. And these parts are known as information frames. Now, by using this information frames, we are converting or we are creating this message frames into the code words. Convolution code is using two parts. First one is it is using shift register, and second one is logic circuit. Now, what is shift register? Basically, the information frames will be of specified amount of bits. Suppose let us take as the L number of bits. So we are dividing our data into predefined specific amount of bits. Suppose here it is L number of bits. Then after we are calculating on your predefined information frame data. Likewise, in example, suppose I am having large amount of data in which I am dividing my data into information bit frames M0, M1, M2 and so on up to I am having the data sequence. Now at the receiver side or at the sender side, ultimately they are doing the XOR operation, or we can say the modulo 2 addition operation on your first and second information frames. Like M0 and M1 data bits are being XORed with each other. Obviously, the number of bits in M0 and number of bits in M1 are equal. So the calculation will be so much easy. We are just doing bit by bit XOR operation. By this bit by bit XOR operation, we will generate the new code which is known as the code word frame. That will be of n number of bits. Okay, so now what we are doing, this particular code is known as the tree code due to the fundamental that First of all, we are calculating the logic circuit XOR formula on M0 and M1 first. Then after, we will get the N1. And in next frame, whatever shift register is doing, it is shifting one position to the right side. Okay, so now my M2 data frame will be selected, but it will do the XOR operation with the previous calculation, that is N1. Okay, so now N1 will be calculated with M2, and by the N1 and M2 XOR operation we can get the N2. In next shifting we will have N2 and M3. Okay, the calculation will be done on N2 and M3, and ultimately we will get the N3. Okay, and so on. And the same process is being repeated at the receiver side. Now, receiver does not need to wait for the whole data sequence to be received. As soon as it is receiving the M0 and M1, it will start decoding. So, here it is overcoming the most of the disadvantages of the Hamming code in convolution code. We are not seeing the convolution code in a very much of extent because that is not required over here. You will not have been asked for the example on convolution code. Okay, so basically in convolution code you are having two parts, shift register and logic circuit. Now, next topic is ARQ, that is automatic repeat request. In the content error, basically we have learned about the error correction and detection technique. But in flow integrity error, when you are having the lesser number of, when you are having the flow control, you require the retransmission and flow control mechanism. So we are using the ARQ. Okay, we are using ARQ for flow control mechanism or flow integrity error. So basically the ARQ is used at the data link layer or transport layer protocol of your OSI model. Obviously it is using for the flow control. Ultimately it is also using the error detection technique, some of the error detection technique to verify that there is an error in your received bits or not. If there is error, then it will request for retransmission. Okay, so error detection techniques are being used. The ARQ is basically working on PDU. Now, what is the PDU? PDU is nothing but the packet data unit. The packet data unit is ultimately what your whole message is first of all being divided into smaller parts, and that smaller parts will have some sender address and receiver address and sequence number on it. Okay, so we are transferring our packets, and that packets is known as the packet data unit with the proper information of source to destination and error control mechanism on it. So there are basically three types of error can be there. First one is lost PDU. That means the receiver is failing to receive the PDU. Okay, second one is damaged PDU. The receiver is getting the PDU, but the data bits in that PDU is corrupted. And third one is, you already know about the handshaking mechanism. Okay, if we talk about there is a sender and there is a receiver. When the sender is sending something data, then receiver must acknowledge it that I have received the data or not. Okay, so this particular acknowledgement can also be lost. So here for the whole flow control mechanism we are using the ARQ. But ultimately ARQ is also dependent on the another kind of protocol, which is the sliding window protocol. Now what is sliding window protocol? Before that, first of all, we need to count the sequence number of PDU. Suppose for k bit filled, the sequence number range from 0 to 2 raised to k minus 1. That means, for example, suppose I am having 3-bit filled data. So the sequence number of PDU will be given from 0 to 7. That will be counted like 0 to 2 raised to k, that is 2 raised to 3, 8, 8 minus 1 is 7. So now for 3-bit sequence data, I will have the sequence number of PDU starting from 0 to 7. Okay. So look over here. In sliding window protocol, we are having the at receiver side and transmitter side, both the side with the same size of window. For our example, the window size is 7-bit. Okay, so ultimately what we are doing, we have just measured on one particular sequence our PDU sequence range, that is 0, 1, 2, 3, 4, 5, 6, 7, then again 0, 1, 2, 3, 4, 5, 6, 7, and again 0, 1, 2, 3, 4, 5, 6, 7. So same window is being established at the receiver side. Okay, so now this particular window will have the bit, this window can have the size at the same number of your sequence number or lesser than that. Okay, but we are having in our example only 7-bit slide, same as your the sequence number. Okay, now you can see the highlighted portion, and this portion is what your window. This portion is window. This portion indicates that from 0 to 5, okay, or all the above, all the left side bit PDUs are already sent to your transmitter. Okay, and your window will be shifted to one right as soon as it will get the acknowledgement of the last frame transmitted. Okay, as soon as the transmitter will get the acknowledgement of PDU 5, it will shift to the size 1 to the right side and send the next PDU, that is 6. Okay, ultimately same fundamental will be done at the receiver side. At receiver side, as soon as it will receive the packet or PDU, it will give the acknowledgement, and as soon as it gives the acknowledgement, the window will be shifted to right. So this whole mechanism is known as the sliding window protocol. Now there are basically 3 types of ARQ. First one is stop and wait ARQ, second one is go back and ARQ, and third one is selective repeat ARQ. Ultimately, sliding window protocol is being used in these 3 types. So first type is stop and wait ARQ. In stop and wait ARQ, we will look for the sender and destination timeline. Okay, this is what sender and destination timeline. The logic behind this stop and wait ARQ is kind of, first of all, we will send the first PDU, which starts from PDU 0. Okay, the sequence number of first PDU is suppose 0. So we are sending our first PDU, and at receiver side, as soon as it is getting the PDU, it will acknowledge it. After getting the acknowledgement, the next PDU will be sent. Till this amount of time, your transmitter will remain idle. Okay, till this amount of time, your transmitter will remain idle. So if we talk about the 3 types of error, that is, first one is lost PDU. If the PDU is being lost, that means you are not getting this 0 number PDU at receiver side. Okay, so after waiting for the some amount of time for acknowledgement, the sender will retransmit the data frame again of the same PDU. Okay, if we talk about the second one, that is damaged PDU. Suppose your 0 is send 0, your PDU 0 is being sent to your receiver successfully, and it is also sending the acknowledgement successfully. Now the sender will send the next PDU with the indication or sequence number 1. Okay, suppose this PDU is having error. After calculating some error detection technique, this PDU is having something error. So ultimately the receiver needs to send the negative acknowledgement, or we can say the request for retransmission. Okay, it will send the negative acknowledgement with the same PDU ID. So the sender will have the negative acknowledgement and it will send the same PDU again. Okay, as soon as it will get the acknowledgement, the positive acknowledgement of the received PDU, it will send the next. Till that amount of time, it will remain the idle. Third error was the lost acknowledgement. Suppose this acknowledgement is lost. Okay, suppose this acknowledgement is also being lost. Then the sender will wait for some amount of time, again the predefined time, and after that time is collapsed, it will send the same PDU, that is packet data unit 1, once again, because it is not receiving the acknowledgement of the previous one. So this is all about the stop and wait. What is the disadvantage in stop and wait? The disadvantage is that basically your sender is remaining idle for some period of time. Okay, even if there is no error or nothing is being lost. So your actual bandwidth is not being utilized effectively. So this particular disadvantage is being overcome in next ARQ type, that is go back and ARQ. Now the concept is what? In go back and ARQ, what we are doing? We are sending the acknowledgement for bunch of data rather for single individual packet. That means you are getting the acknowledgement or not, but after some predefined time, the sender will send the next PDU. Okay, I am just writing the PDU number only. Okay, I am not writing PDU 0 or PDU 1, only the PDU sequence number. So this first PDU is being sent, 0th PDU, then 1, then 2, then 3, then 4, then 5, then 6, continuously. Okay, your acknowledgement will be sent for bunch of sequence. Suppose the 0 is being received perfectly, then after 1 is received perfectly, and then after 2 is received perfectly, but we are sending the acknowledgement with the ID 2. That means from start with this PDU sequence or previous one till 2, this 0, 1 and 2 is being received successfully at the destination side. Okay. So what about if I am having the negative acknowledgement? So then after the sequence of or transmission of your PDU is continuing, okay, it is also continued. So 3, 4, 5 and 6 is also being sent. But when the destination is checking for the data unit 3, okay, the data unit 3, they found the error in it. So they will, as soon as they found the error, they will send the negative acknowledgement. And the sender will now track. The sender will check for the previous data, okay. It will go backside and will check for that what sequence number was received successfully, and it was still PDU 2. So now your sender will again, starting from 3, send the data, will again send the or retransmit the PDUs starting from 3, 4, 5 and 6. Okay, so ultimately the bunch of data, even though you are having the problem in only a single PDU, we are retransmitting the bunch of PDU, which is also the disadvantage of your go back and ARQ. So ultimately go back and ARQ is overcoming the disadvantage of stop and wait, but it is also having the disadvantage of its own. Okay, so this is being resolved in selective repeat ARQ. Now what we are doing is selective repeat. We are just sending negative acknowledgement only. Okay, now the rule is changed. We are not sending positive acknowledgement at all. Okay, we are transmitting our PDUs in a sequence. The retransmission will be occurred only if the transmitter is receiving negative acknowledgement with the ID number of your PDU. Likewise, 0 is being sent, 1, 2, 3, 4, 5, 6. Okay, after sending 6, suppose your sender is receiving the negative acknowledgement with the ID 4. So it will send only PDU number 4 again. Okay, retransmission will be for only PDU 4. Then it will continue with the previous sequence number. Okay, we have left till the 6. So again retransmitting a 4, it will continue for the 7. So this was all about the ARQ. They have the 3 types. Okay, so just a summary of this whole lecture. First of all, in this whole topic, first of all, we have learned about the error, then after error detection technique, that was the parity bit check, CRC and checksum. Then after we have learned about the error detection technique, that was the Hamming code, and then after the convolution code. Hamming code is important, parity is important, CRC is important, checksum is important, because we can be asked for the example of it. Okay, then after we have learned about the sliding window protocol and ARQ. ARQ is basically having 3 types: go back, stop and wait ARQ, go back and ARQ, and ultimately selective repeat ARQ. And selective repeat ARQ is being used nowadays. So thank you. We will meet in our next lecture.